What is this, Lady Ada?
Hello, everybody. Welcome to yet another Hangout on Air. It's the show and tell. Adafruit peeps here in town. We got Aiden, a special guest. Hey, Aiden. It's me, Lady Ada. With me, Mr. Lady Ada. We've got an exciting show and tell. Post-Halloween, it's getting colder, it's getting darker, which means you should just stay in and do LED projects.
Yeah, a lot of people don't know this. If you're on the show and tell enough, you get this like yogurt card like Aiden has, and you get multiple little stamps on it.
And eventually
you get transported to Adafruit.
Yes, we pull him to the computer.
Yeah, so make sure you hold on to that yogurt card.
Yes. So we got...
There's sandwich cards. There's other type of cards, but that's the thing I remember the most.
Yogurt, yeah. So we have a half an hour of joyful fun. All these Adafruit community folks showing off and sharing their projects, whether it be 3D printing, electronics, accessibility, costuming, sewing, whatever they're making.
If you can make it, we can show it.
It's super cool. I'd love to see it. So let's kick it off with some Adafruit P, see what they're up to. Noe Perdro.
Hey everybody, we have a Raspberry Pi 0W project today. Do you guys remember this adorable little cute guy? This is Boomy, our Circuit Playground character. He's a boombox, and originally we made this for AdaBox 04, but recently this week we remixed Boomy for a Pi 0W speaker bonnet project. So the speaker bonnet is a nice little audio amplifier that you can add to your Raspberry Pi, and we kind of remixed the box so that Boomy can play AirPlay. It's an AirPlay emulator using SharePort Sync. So it's a nice little enclosure. We have, of course, all the stuff inside there, and we kind of went a little bit fancy with the case and added this acrylic window in the back so you can see things. It's even edge lit with this awesome little LED backlight module, which is kind of used for displays, but Lamar, you're able to source out just the backlight module, so that works really well.
Yeah, isn't that great? No, I remember
awesome.
I found them once on some one of those surplus sites. And I was like, oh my goodness, these are so cool. I got to stock them in the store. Because they only had like 5. They're like, we have 5 in stock. And I'm like, no, I'm going to stock these because they're just so perfectly diffuse white.
They are. And they come in several different sizes too. So the medium one is the one that fits perfectly inside here. And this is a really nice AirPlay speaker. So I'm just playing some music on it. And a really good work on the button. On the buttons are really nice. They're the Ninja Flex buttons. They actually do the volume so you can turn it up really loud. We can do mute, so we can mute it if we want. It's quick access. So a lot of different things in this project. So check it out if you haven't already. It's on the Adafruit Learning System, and I'm going to mute Boomy. So check it out. It was on 3D Hangouts earlier this morning. One
of the things I'm proud of for this, because you wanted a power off button, and I was like, well, there's no display, so I can't tell people that they just turn it off. So I have the text to speech on the Raspberry Pi, and it says turning off Raspberry Pi now, you know. So
I actually, you know what's funny is I actually have it say Boomy is shutting down now.
Oh yeah,
you could just make it say whatever you want. Like I'm gonna go by.
Yeah, it's awesome.
Yeah.
So
I would do it now, but it takes like 4 seconds to power it down.
Right? When you have Linux, it's one of the neat things. All right, thanks for the update. Noe Perdro. Next up, JP.
Hey, how you doing, everybody?
Hello.
Oh, so I did a project today on my live stream. Normally my live stream is tomorrow on Thursday, but I had some conflicts, so I went today. And what I did was I started with, this is the Arduboy. This is one of the Kickstarter edition ones. So we sell the very cool white Arduboys in the store in Adafruit. So Arduboy is open source. It runs on a 32U4. You can program it in Arduino. And the nice thing I found is that when I took it apart, I opened it up, and I found that there are big fat pads that you can solder to in order to make something insane like this. So this is my Arduboy, except now it's tethered with all these little 30-gauge silicone wires to a full-scale joystick. So I'm going to set it over here and switch cameras so that you can see why I would bother going through this, and the answer is Picovaders, which is a Space Invaders clone. So let me switch cameras for a second and check out the joy that is a real arcade joystick running on the Arduboy.
Ooh, that looks fun.
Super fun. My son came over and he was like, "Oh wow, this is playable now." You just need glasses, but that's what I built. If you check out the, I'll leave that. I'll turn that off. If if you check out the live stream, you can see all the fun of getting in there and peeling off the back cover of it. It's got a really fun silk screen with lots of fun 8-bit graphics and stuff on there. And it's really straightforward. Now you could use, since you can program it, you could use this for anything you want. I did it just because it's fun, and it actually is much more playable. That game. I've got other games that I play, like Circuit Dude, which is a real fun puzzler, and that's fine on these controls. But if you have something like a Pac-Man or a Space Invaders, you want the full joystick, then this is a bizarre way to do it. Noe Perdro mentioned in the chat when I was doing my live stream, someone had asked, what's the point of a project like this? And one answer is assistive technology. So since it's such a great little programmable small game machine, it's lightweight, it's small, you could have that somewhere that you're looking at it, but some people might not be able to use the thumb pads on it, which is, it's restrictive, it's tiny. So having other types of controls that could be foot controls, that could be large joysticks like this, it's very easy to attach those to this. There's no guesswork. The schematics are out there. It's an open source project, so you can look on the Arduboy forums and see everything about the pinouts and go to town. One other thing I found is that you can hook up a bigger piezo to it. I didn't do it today, but I was testing it out last night, and you can get it to be much, much louder, which is fun. So there's a lot of potential hacks for that little Arduboy.
Okay.
All right. Thanks for the update, JP.
All right.
Watch that stream.
Chris Young. Hello, Chris Young. How are you?
Hello. I switched already to screen share here. Click minimize. Wake up. Click minimize. Go to sleep. Okay. I'm finally starting to learn Fusion 360 after doing using Blender as my CAD program for 2.5 years. And this is a little project, this little wiring harness, there's a little lever switch on the end of it. And this is a gadget that was made for me by the people at St. Vincent Hospital about 30 years ago when I couldn't work the nurse call button. And they said, well, could you work one of these little switches? I said, yeah. So they wired up this thing for me. And they said, when you go home, take it with you. Anytime you come back, bring it back with you again. So that's what I've been doing for like 30 years now. Anyway, last December, when I was in the hospital, I was having a little trouble holding on to it. So I designed a little 3D printed ring to put on the end of it. I actually designed this on my laptop in my hospital bed, used TeamViewer to ship the files back home, and printed them back the next day, and we glued it on there. We had to go through a couple of iterations to put that angle at a different angle. And there it is in my hand in the hospital. You notice I've got a huge piece of strain relief on the tail end of the micro switch, and that was giving me some problems. It was bumping into my arm. So I stripped all that off, turned the wiring around, and now I've designed a new ring system. And this is the first practical thing that I've ever designed using Fusion 360. And it's been quite a steep learning curve. Like I said, I've been using Blender for over 2 years, and it's really different. But it's really cool too. It's got nice rounded edges, and all that stuff is really easy to do. Thanks to Bill Benko for a lot of help he's been giving me. And so finally, here's the printed piece with a little switch glued in it. And I hope I don't have to use it for a long time, because I only use it when I'm in the hospital. Got one other project. This is a little aluminum bracket that fits on the armrest of my wheelchair. You can see it's just a U-shaped channel. We've kind of notched it out and molded it together with a pin. And there's a little keeper pin. It wraps around the upright of my armrest on my wheelchair. There you can see it installed. I've used this bracket for a lot of things over the years, but right now I'm using it to hold my my phone and my remote. Here it is folded out of the way under my armrest. Works really handy. And here it is with my phone bracket sitting on top of it. Now the blue box on the left is my little custom infrared remote and Bluetooth switch control device. And I used to have a big heavy TV remote sitting over there next to the phone, and it would always try to fall over to the left. So I put a little metal tab down at the bottom. Maybe you can see right below the black knob. there's a metal tab there. And that would keep it falling left. Well, now that little feather wing box is not so heavy. Now it wants to fall over to the right, like that. So I had to come up with something different. And so again, I went into Fusion. The sort of dark pink or reddish thing is a roughed out model of what my beam looks like, the bracket looks like. And then the purplish pink thing is the device that I've actually printed. And there's the device itself. And now here it is, 3D printed. And there it is. It's slid onto the beam there. And then you slide it over to the right, and it catches that tab. And now the phone doesn't fall over. So those are just a couple of little things that I've been doing, trying to teach myself some Fusion 360. And nothing spectacular, but just little gadgets that make life easier. And as always, for more information about my stuff, go to tech.cyborg5.com. And if you get a minute at the end of the evening, come back to me and I'll tell you about this photo. This is the photo I took of actor Eric Braeden, who played Dr. Forbin in Colossus, the Forbin Project. And you told a story about that on Ask an Engineer last year. And if you have some time at the end, I'll tell you a story about this photo.
Okay.
Yeah.
For now.
And for folks out there who visit Chris's site, he did a fantastic job blogging, making HTML pages that, it tells the story of the last, 15, 20 years of the internet. And it's there. It's something that reminds me we should always make sure we're all publishing, because you get to look back and say, oh, this happened. This is the first time someone emailed me, or this is a HTML page that I had that was a resource and it turned into a project or something like that. So thanks for always publishing, Chris.
Okay, thank you.
Okay, we'll try to come back.
That was Pimp My Wheelchair.
Yeah, that was.
Yeah.
All right, next, Sophie. Hello, Sophie. Welcome back. How are you?
Hey, Sophie. Oh, we can't hear you. We can see you, but I can't hear you. Do you do maker charades? Ah!
We can, if you need audio, we can come back to you, or you can just hold up the project. We'll come back to you.
Come back.
Okay, great. All right, next, Dave. Hey,
Dave. Hey,
How's it going?
Dave.
Unmute your mic and show your project.
There we go. Hey.
Hey.
Yeah, long time watcher, first time shower.
Well, you're part of the community.
Yeah. I've just gotten into it really heavily lately. So what I have is I needed a way to store things at a specific relative humidity. And you can buy these little packs that are sort of like silica packages.
Mm-hmm.
Let me hold it up. But they're set for a specific relative humidity. So they'll both absorb as well as emit moisture. Although they run out of whatever's in them over time, they get saturated one way or another and stop working so well. So I wanted to be able to monitor it. So actually, I'll pull that off again. I decided to use something small, low power. So I went with a Trinket M0. So you can see on the board, the first version of the custom board, I have a Trinket M0. I have the TPL 5110, which cycles it on and off, as well as a piezo buzzer. And that goes through the jar lid, and on the inside is the SI 7021. There's a piece of header going through the jar lid to connect them. So when it goes on the jar, and when the TPL 5110 tells it to wake up, I have it cranked all the way up to its maximum, which is like a couple of hours. It comes on. Oh, and you should be able to hear it if I hold it up.
Yeah, I heard a beep.
Yeah, so the piezo, I use like a dropping tone to say, hey, it's too dry, or a rising tone if it gets too humid. So it's on now. You can see the lights.
Yeah.
So it's powered up, and it'll sleep for 20 seconds, check the humidity again, and so it went off again. And it'll keep doing that until it says, okay, the humidity's fine. It's within plus or minus 5 relative, percentage relative humidity, and then it'll turn off.
Neat.
And 2 hours later, it'll wake up again, do it. So yeah, with the Trinket, it's all written in CircuitPython, which is the cool thing.
Very cool,
A
Dave.
little bit of CircuitPython, very low power, and it's got a 500 milliamp hour LiPo battery on it, which hopefully will last for a long time.
Email
It's a bit
support
of
at
a-
adafruit.com, and we'll send you out a sticker for the side of the jar. I don't think it'll affect the readings
Oh, sweet.
at all. You get one of those. And if you remember, email pt@adafruit.com. We're trying to come up with more projects with CircuitPython now that we have it for environmental stuff and things that like, especially young kids can do things like in their environment where it's like, oh, this is humidity, this is temperature sensing, things like that. So if drop me a note, maybe we can fund your next project or we could do a learn guide together.
Cool. Awesome.
Okay, Dave.
All right.
Thanks so much. All right, next up, I'm going to see if Sophie's microphone's back. How you doing, Sophie?
We'll try again. No.
No audio.
No.
We'll come back to you. All right, next up, Jeremy. How's it going, Jeremy?
Hey there.
Hey.
Yeah, it's kind of awesome to be here because usually Wednesday's date night. So I will explain a little bit about the motivation for my project. I'll just show you a couple of little gizmos that I've made over the years. This is something I made for my daughter that it's just kind of a cool little interface. Here's another thing that I made her that lets her figure out what time it is, so she can set a timer. But you can see that the template of all these things is like lots of little wires all scattered around. And I was actually so happy once I learned about silicon-coated wires because it makes this kind of fine-pitch stuff a lot easier. But oh, and here's another one too that I made. It's like a little rotary encoder and makes some noises and stuff.
Wow.
So like what?
Clear cases are great.
Yeah. So
You're awesome.
and you can see again, it's like lots and lots of wiring. So after doing this a bunch of times as a software guy, I'm like, gosh, there's got to be simpler ways of doing this. And so I started thinking a lot about how would you make a network of little devices that work so that you're just stringing everything together with, you know, a little bus, like a field bus. And so I came up with this idea that I'm calling MakerNet. And the idea of MakerNet is, I haven't really rehearsed this, but the idea of it is that you can, is work?
Yeah.
Is that, you know, I have all these little components that I've been designing. Like I've got a rotary encoder here. Here, maybe like this. Got like a rotary encoder here. I've got a little display that you can show where things are. I've been working on a little like a display, an OLED display. And the idea is that they all participate on an I2C bus so that you can kind of plug and play and mix and match. So like in this case, I've got a little, I built my own little, it's like a clone of the feather that I use for my projects, but you can see what I've done is I've added a little jack on here. It's like a 6-pin connector. And yeah, so like in this case, you know, I can twist this little thing and move some lights around. I've got some other components that are like little neopixels on a strip. And, you know, it gets power and signal all over this 6-pin JST terminated connection. I mean, what I really want is this to basically just be like a modular thing so that when I've got projects like this, I can replace them with cool, nicely, you know, nicely abstracted little components. And what I'm doing for all of these little things is I'm using an AT SAMD11 that I've written some firmware for, and it actually runs its own little network stack, so that it's actually, although it's using I2C, it's really sending packets. And what's neat about that is that I've shown that you can actually like bridge packets over a radio network or things like that. So this could be like a really extensible framework for building interactive projects.
Well,
and I've actually been working with some of the guys on Adafruit on a library to do touch sensing, open, you know, an open source touch sensing thing. I took your library and I had actually worked on it myself, and then I basically merged our code bases. But the point is I want to basically just create a bunch of control circuits and then allow them all to be daisy chained. So yeah, and
nice.
I actually made a version of this that you don't need the headers for. This is actually something, my first Tindy store. I made these little things that have been selling really well. It's just a knob with a 4-wire connector. And it, you know, basically lets it, you can just add as many of these things as you want to, and you can reprogram the I2C address using software. You know, you can effectively use it as, you know, a toolkit. So anyway, that's my project.
Thank you so much, Jeremy.
That's awesome.
Email support@adafruit.com. We'll send you an As Seen on the Show and Tell sticker. And if you email me, pt@adafruit, and you want us to post about your Tindy store, maybe that'll help folks buy your stuff so you can keep doing this.
Yeah, no, that'd be awesome. I mean, to be honest with you, I was actually like, I'm making things. I wish Adafruit just sold them to me, and then I could buy them and not have to invent them. But so yeah. Anyway, I'll send you guys a link.
Yeah, and if there's a learn guide you want to do, we can also we're releasing Stemma soon too, which has a way for a lot of these things to talk to each other. Maybe we can
it's
send
part
you
of like
out
the Seesaw. Like that's why we have Seesaws, because we wanted to have basically plug and play.
We can send you some
for,
beta hardware.
Like you've seen like rotary encoders and stuff.
Okay.
Okay.
Yeah, that's awesome. And I, by the way, I would also really encourage you guys, and I'd love to work on this with you. An I2C bootloader would be awesome, so that we can make these kinds of things field upgradable.
Yeah, this is how we do stuff. We talk to people on our show and tell. So, yeah.
Yes.
Done. No,
Okay.
we'll get the whiteboard out. We're like, here's how we'll do it. Start doing it.
All right.
Thanks. International interstate project planning.
Yes.
That's how we're going to do it. Okay. I'm going to check with Sophie and see how her microphone.
Sophie.
All right, Sophie, how's your microphone?
Not so much.
Your microphone, you want to hold up your project? You want to come back next week? We'll hold it up anyways. Well, of course, yeah, this is the thing, and it talks, and it's, and you got a big battery.
Bigger battery.
Yeah, you got a
bigger
big battery. More photos.
More fun.
All right,
more joy.
Come back anyways, and plus, I think you're working on a learning guide later.
It's always good to see you.
Yeah. All right, that's a cool camera that talks.
Yes.
All right. Okay, if everyone can keep it to 1 minute-ish, we can get to everyone. Codingpro shows your project.
Give us your update.
Hello. I'm not working on the pinball machine anymore, or for now. But today I was working on a kit, maybe for people to learn the basics about building things. And a lot of kids I know play Minecraft, and so I made a redstone block out of cardboard, and it has two little pins on the bottom here.
Mm-hmm.
I'm going to take an LED and attach it to both. Let's see. Wrong. Lights up. Might not be able to see it that well.
It's got a battery inside?
Yeah.
Cool.
But, I'm working on making like a magnetic board. You can put like the blocks on and then connect LEDs with like whetstone wire, which is like some wires connected to each other.
That's cool. You can build stuff in real life, just like Minecraft, but in physical space.
Mm-hmm.
That's neat.
All right, cool.
Good
Well,
work.
there's probably enough room on that block for As Seen on the Show and Tell sticker. So, of parent or friend, email support@adafruit.com. We'll send you out a sticker.
And come back when you have your next magnetic board up.
Yeah.
Check it out.
Cool.
Lots of blocks.
Okay, we still got a few more minutes, so we're going to go to Radomir and then Adam. If both keep it to about a couple minutes each, we can get to both of you. Radomir, welcome back.
Hey, welcome back.
Oh, hi. So I was trying to show that last week, and it didn't work back then. Turns out there were some delays needed for the display to actually execute the command that was sending them. So this is a game console. Switch on the left. This is a tiny game console that you can program with.
Ooh, cool.
And I'm not sure if it shows properly.
Yeah, I see these three characters.
Actually, yeah, those are just some test sprites that I'm using for developing the sprite engine for it. And you can actually walk around. And this weekend I was working on it. I added text support, so you can see some example text in the corner there. That's actually, if I walk there, you can see that I can walk behind the text. So the transparency and everything works. And of course, I will be working on games for it next. And probably some simple RPG game for Astels, some adventure game.
I can't wait to see if it works.
Yeah.
All right.
That's it.
Good stuff, Radomir.
I'm waiting. I should receive the PCB for you can see this is version 3.
Yeah.
I should receive PCB for version 4 for this tomorrow. actually. And it will also have sound. So that's an improvement. And I hope that version 4 will be fine. So.
Okay, outstanding. Well, I know you're in Discord and everything. When you're ready to have it on Tindy, or if you want to have us blog it up or whatever, just let us know. And if you want a sticker, of course, you know. We'll send you
Okay.
All right, thank you so much, Radomir. All right, Adam, play us out.
Zooming in. Enhancing.
This is Adam's performance art stage.
Yeah, we're just looking. I kind of like if you zoom in and out, it kind of gets this cool flickering.
I think he's merged with the electron microscope, and he's in the electron microscope trying to get out.
Yeah. Look, it's just getting so high def. Smooth traces.
I'm just gonna watch this for a while.
Okay, so hopefully you can still hear the music some. But as you can see, the microscope's working significantly better than it was in the past. I actually have a full screen monitor right now. And so I can start to do some pretty cool stuff in it. Namely, I've got the grid eye. I believe it's the AMG 8833 thermal camera in it right now. And we're actually looking at what I believe is the sake of its name, the grid that is the thermal sensor.
The grid eye, yeah.
Yeah, I know, it's surprising, right?
Grid of eye.
This is actually a really cool thing to kind of take apart because it's got so much more exposed silicon than a lot of stuff. And you can really kind of start to infer a lot about how it works just by zooming in on it, which I have the perfect tool to do. So if we look here, we can start to see that the entire grid is connected by these basically traces in the silicon that go up and down. And then you'll start to get, then side to side, you've got basically a bus that goes along there. And you can see we've got silicon that ties in. And you can kind of tell there's some different layers going on here. So we can punch in a bit further. Let's see, go to 10E3. And so we start to see how these how the silicon is connecting to these different layers. So you can see, like, as they do these photoresist masks, they'll build up layer by layer and then just have kind of a conductive square be sputtered on every time you need to make contact between layers. So you really are starting to be able to tear into some really neat stuff with the microscope, and it's really starting to hit its stride, which is I'm really happy about because it's taken a long time to get here, or to get a scope that can do this.
We got to get you a BME 680 because that's going to also have some cool. There's multiple dyes.
Yeah.
And they're all exposed because it's got a Mach sensor and a temperature and humidity. So that'll be a good one.
I think I had the BMA 680 under my ISI a while ago, so I'll get that back under here at some point. But no, that's another fun one. That was another fun one to do.
All right, well, see you next week and more. And thank you for showing the progress. And this is amazing.
Yeah, good work.
If you got anything you want to see, Andrew, let me know.
We'll send them to you.
All right, Chris, do you want to tell us the Forbin story before we get out of here, Chris?
Well, if you guys just a minute, that photo, I posted it on a website back in 1995. And one day, someone sends me an email and says, hey, I saw your photo of Dr. Forbin at the Indy 500, and I watched that movie late last night, and I fell asleep before it ended. And I did a search on the internet, and here was the only reference I found to that movie. Please tell me how the movie ended. So I won't spoil it for you people, but I did tell the guy. But I mean, this was 1995. This was pre-Google. So I don't know what he was using to search out my stupid little web page of my, how I went to the Indy 500 and took celebrity photos. But it really freaked me out that I could post up this one dumb little picture and get emails from somebody.
The thing is that the internet worked better back then because you could actually find what you're looking for. Now, now if you type Dr. Forbin in there, you'll just get a...
You can't email people on the internet and tell them, like, hey, what's the ending of this movie? Get a reply.
It's just ads. You'll just run into a bunch of garbage. That's when the internet worked.
The other thing was the same actor played on a 1966 TV show called The Rat Patrol, where he played a German officer. And on my webpage, I described him as a field marshal. And a couple of weeks after I posted that, I got a nasty letter from some World War II fan who said, don't you know he wasn't a field marshal? He was just a lieutenant or something. I'm sorry, I'm not an expert on Nazi emblems like some people are. So anyway, I've gotten strange emails out of that photo.
Thank goodness it wasn't Twitter.
It was the early days of the internet, and I was just shocked that somebody would find this one little photo out there in cyberspace.
No, it was cool. They probably use like Alta Vista or like Lycos or something.
It had to be Alta Vista or Lycos.
Yeah.
I doubt Yahoo would have indexed me. I wasn't that big. But anyway.
All right.
I'll blog about it sometime.
Thank you so much, Chris. See, this is why I published my article, because I knew someone out there probably had their own Dr. Foreman story. So,
yeah.
All right. Well, thank you so much, Chris. Thank you, Adam. Thank you,
by the way.
Dave. Thank you, Jeremy. Thank you, John. Thank you, Noe Perdro. Thank you, Radomir. We're here every single week. Thanks for being here with us tonight. On the other side of the camera tonight. We'll be on Ask an Engineer in just a few minutes. And
plenty of aid in time.
Thanks for making this the best half an hour of our lives every single week, everybody. Bye-bye.
Ciao.
Wee.